Dear students, we now move on to the various steps which are involved in writing a balanced chemical equation. There are some steps we need to keep in mind. So let's see these steps. Again, we have the same chemical equation which we learned before in the previous slides about the burning of magnesium ribbon in air. So first step is the reactants are always in a chemical equation. The reactants are always written on the left hand side, while the products are always written on the right hand side. As you can see, my reactants, who are my reactants? Magnesium and oxygen. I have written them on the left hand side, whereas if you can see magnesium oxide MgO, I have written it on the right hand side. That is the first step we need to keep in mind. Second, if there are two or more reactants or products, they are always separated by a plus sign between them. As for example, in the same chemical you can see on the top, you see there are two reactants, magnesium Mg and oxygen O2. And what sign have we put between them is a plus sign. Okay, no other sign is allowed. Minus, division, multiplication, nothing is allowed, only plus sign. Thirdly, the reactants and products are always separated by a arrow which is pointing towards the product side. So in a mathematical equation, the left hand side and the right hand side, what do we put in between them? We put a equal sign. But in a chemical equation, we have to put a arrow. And where is the arrow pointing? Towards the product side. Okay. Next, certain conditions like specific temperature, pressure, catalyst, etc., which are needed to bring about some reactions, are mentioned on this arrow. You can see the example on the top, the chemical which on the top. What is the condition required for this reaction to happen? Heat. In other words, you need to burn the magnesium ribbon. So the heat word has to be mentioned on the top. So the conditions are always mentioned on the arrow. When heat is supplied to bring about a reaction, triangle sign is indicated above the arrow. So if you want, instead of this, as you can see here down, instead of writing the word heat on the arrow, it's the same chemical equation which is there at the top. I've written it down, but instead of writing heat on the arrow, here I've shown a triangle sign. So triangle sign also indicates heat. It means the same thing. The next step, the fifth step, special information or names of the reactants and products are written below their formulae. For example, concentration of the acid. We need to mention whether the acid is a dilute acid or a concentrated acid, because it makes a big difference. Let's take a small example here. Like, see this example, can you see here? The The first reaction, copper plus HNO3. HNO3 is nitric acid. So when copper reacts with nitric acid, concentrated nitric acid, you get copper nitrate, NO2, that is nitrogen dioxide, and H2O, that is water. But if copper is reacted with dilute nitric acid, as you can see in the second reaction, you get copper nitrate, same thing, but you, instead of nitrogen dioxide, when you react to dilute nitric acid, you get nitric oxide. So that is the difference, and you get H2O. The products are more or less the same. In both the reactions, you are getting copper nitrate and water, but with concentrated nitric acid, you got NO2. NO2 is what? Nitrogen dioxide. And with dilute nitric acid, what did you get? You got nitric oxide. Can you see such a big difference? So that's a very important that you mention what is the concentration of the acid and any other special information which you know about the reactants. Let's move on to the sixth step, dear students. So the sixth step that you need to keep in mind while writing a balanced chemical equation is the physical states of the reactants and products are mentioned along with their chemical symbols and formulae. So for all the reactants products, you need to write down their physical states, whether it is solid, liquid or gaseous. The gaseous, liquid and solid states are symbolized as G for gaseous, L for liquid and S for solid respectively. As you can see on the in the equation on the top there, the burning of magnesium ribbon in air, I have written the magnesium is in the solid state, oxygen is in the gaseous state, and the MgO, the magnesium oxide powder, will be obtained in the solid state. Now, going on, if the reactant or product is present as solution in water, okay, that means the reactant or product is mixed in water or dissolved in water, it is symbolized as AQ. AQ means aqueous. Gases can also be shown by an upward arrow sign, while precipitates are shown by a downward arrow sign. Now gases usually move upwards. So instead of writing G for gaseous, you can also show a upward arrow sign for gases. And for precipitates, you have to show a downward arrow sign. Now, what is a precipitate if you ask me? You have learned last year that when, no, what are precipitates? Precipitate is nothing but something which settles down during a chemical reaction is called a precipitate, something which settles down. Let's say for example, now this is not exactly a chemical reaction. Let's see, if I put sand in water or soil, no, in water, what will happen to the sand or the soil? The sand and the soil will settle down, no, and the water will remain on the top. So that sand, since it settles down, I can call it as a precipitate. Okay. So let's see some examples of this. This reaction you learned last year, when carbon dioxide gas is passed through an aqueous solution of calcium hydroxide, you get a white insoluble precipitate of calcium carbonate. If you remember this reaction which you did last year in your acids and bases chapter. Okay, so what do you mean here? What is that? As you can see, I have shown the carbon dioxide gas by what sign? Upwards arrow sign. So instead of writing G for gaseous, because carbon dioxide is a gas, I have shown an upward arrow sign. And AQ, why did I put AQ? Because what did I do? I took calcium hydroxide powder and I mix it in water. So, and that solution is called a aqueous solution. Why? Because I mix calcium hydroxide in water. So I call it an aqueous solution of calcium hydroxide. Also, what did I get when I passed carbon dioxide through an aqueous solution of calcium hydroxide? I got a precipitate, a white insoluble precipitate of calcium carbonate. So the calcium carbonate, it settles down, okay, and the water remains on the top, H2O remains on the top. So that's why, because it settles down, I have shown it, it's a precipitate. I have shown a downward arrow sign for CaCO3, that is calcium carbonate. I hope it is clear, boys. Now what? Okay, upward side arrow sign, downward arrow sign, and AQ for aqueous. Okay, let's see one more reaction. If I take this magnesium oxide powder, which I get in the reaction on the top, the equation on the top, no, the reaction. If I take that magnesium oxide powder and I mix it in water, I will get a aqueous solution of magnesium hydroxide. What will happen? The magnesium oxide will dissolve in the water to give me MgOH2. OH2 is what? OH is what? OH is magnesium hydroxide. So I get an aqueous solution. Why aqueous? Because I mixed magnesium oxide in water. So whenever something dissolves in water, I call it an aqueous solution. Okay, only in water, boys, nothing else. Like example, if I put sugar in water, no, sugar dissolves in water, right? So I will say it's an aqueous solution of sugar. Why? Because I mixed the sugar, or I dissolved the sugar in water. Now, why is it so important to mention the physical states of the reactants and products? You may ask me. So why is it so important? It's understood, no, more or less. Like for example, if you see this reaction, the third reaction, write down aluminium Al plus water giving you Al2O3 plus H2. Now what will you think normally speaking? You'll think that aluminium is usually solid state, or it is a metal, no, solid state. Water. Now water, you generally what you'll think, that water must be a liquid water, and that you what you'll think, that aluminium will react with water, liquid water, to give you aluminium oxide Al2O3 and hydrogen gas. But sorry to say, aluminium will never react with water. So so that's why you have to mention the physical states. See here, can you see here? I've shown you down the correct reaction with the physical states. Aluminium plus water in the what state? Gaseous state. In other words, aluminium does not react with liquid water or ice or whatever. Aluminium reacts with water only in the gaseous state. In other words, aluminium reacts only with steam, only with hot steam. Only then will you get aluminium oxide and hydrogen gas. So understand why it is so important to mention the physical states, because if I don't write what state water is, that person may generally think that we have to use liquid water, and that reaction will never happen. It will never happen.